Okay, I think we're ready. 3.3 similar figures and scale models. And so first off, what we want to talk about are similar polygons. Similar polygons. And we did talk about similar polygons back in pre-algebra. They are shapes that are, it's a closed figure. So technically it's a simple closed curve made of line segments. Geometry, you'll get that more importantly, and you'll have to know that verbatim. But that's a polygon, and you guys know what polygons look like. A popular three-sided polygon, which is the least sided polygon you can have, is a triangle. And a four-sided is called a, that's only one kind of four-sided. A four-sided is called a quadrilateral, right? A fifth-sided is called a pentagon. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. 10 is, did we do 11? No, n-gon is like as many as there are. I can't remember 11. What was 11? We did 12. 12 is a dodecagon. But anyhow, all right, so that's the idea. Now, similar polygons, we're talking about two of them. And what makes them similar? Well, these two parts. All the angles are congruent. All the angles are congruent, meaning those angles are exactly the same size and shape. Let me do a pentagon here. Let's fill it in. Let's make it colorful. What do you say? Fill. Give me fill. Blue. Let's go yellow. Like yellow. Okay, so we have a pentagon there, right? So now I have another pentagon. But those two pentagons are similar figures. Now, they're also regular pentagons. Does anybody remember what regular meant when it went in front of the pentagon? Like a stop sign is a regular octagon. Anybody remember? Okay, regular meant all the angles are the same length or same measure, and all the sides are the same length. So those are two regular octagons. Let me get rid of those because really they don't have to be regular, and I'm just going to have to, goodbye. Let's see, can I do a non-regular? Let's do a triangle. Whoa. Gives me limited capability, but that's okay, that'll work. So let me do a triangle here. Let's fill it up. No, I don't like blue. I do like blue, but not in my triangles. Okay, so again, let me get a similar triangle. Whoa. Let's undo that. No, just a triangle, please. We're going to like put it inside there. Things that do things. Okay, so there's an illustration of similar triangles. And what we're saying is, and they're oriented the same way. Remember the markings? That angle is going to be congruent to that angle. They correspond. This angle down here looks like a right angle, and it's congruent to that angle, right? Both of those are 90. And this angle up here in this corner is congruent to that angle in that corner. Okay, the angles are congruent. Now, are the sides congruent? Does that side look to be the same length as that side? And the answer obviously is no. So you can't say the sides are congruent, so don't do that. So if the sides aren't congruent, they must be. Not similar, they must be proportional. Hence, we're doing similar figures right now because we just talked about proportional a couple lessons ago, right? So the sides are proportional. So I'm just going to make up a number. Let's suppose this was 3, and just to make life easy, suppose that then we're 6. If this was 4, what's this bottom one here going to be? 8. And right triangle, do you guys remember a special right triangle with a side 3 and the other side 4, and the hypotenuse has to be 3, 4, 5. Boy, you guys have memories like elephants. Or do elephants have good memories? They have good memories, then you don't have a memory like an elephant. All right, so if that's a 5, then this one must be a 10. And they're proportional. 5 over 10 equals 3 over 6 equals 4 over 8, right? Or vice versa. 10 over 5 equals 6 over 3 equals 8 over 4, right? Proportional. So the angles are congruent. The sides are proportional. And do you guys remember how we can do this without even having the figures, going by the way they're named? So angles first. Angle A has to be congruent. Oh, by the way, you remember the similar signal or symbol for similar? And what is that called? It's a, come on, it's a key on the keyboard. It's a tilde. It is a tilde. All right, that is the symbol for similar, is the tilde. So angle A is congruent to angle X. How did Andrew figure that out? A was listed first there, and X is listed first there. And I'm an orderly person, so I'll do angle B next. And angle B is congruent to angle Y, because we have to know. And angle C is congruent to angle Z. And we can do the same thing with the proportions. Only remember, to name a side, it takes the 2 endpoints. So if I say AB, then the bottom should be, nope, XY, right? And that will equal, I got to stay with now the triangle ABC's on the top, so I got to go BC on the top. And therefore I go YZ on the bottom. YZ, such a wise guy. All right, and then I go CA on the top, and I go ZX on the bottom. Or, hey, remember, proportional, you can flip everything upside down. So we can do XY over AB, so just flip them all upside down. YZ over BC equals ZX over CA. Or vice versa. Whoever came up with that, vice versa? Speak Latin? Anybody, you guys taking Latin yet? Is vice versa Latin? All right, assignment. Ask your Latin teacher what vice versa means. All right. Well, I want the translation in Latin. Vice versa. And she'll do what I'll do when I'm asked a question I don't know. Go to the internet, right? All right. Used to have to call a librarian. All right, that was boring. Okay, so we know all that, how to name and how to go on what's congruent, what's proportional. Now, how to use these proportionals, these proportions, 2 at a time. For example, you don't need to write this in your notes, but maybe you'll use those 2, right? Maybe you'll use those 2. Maybe you'll use these 2, right? And that'll be the proportion that you solve. You know 3 of the things, you can find the 4th, right? Maybe you'll use these 2. And again, you know 3 of the things, you can find the 4th, etc., 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 etc. Okay? So similar. Okay, so here's a problem. If triangle JKL is similar to triangle PQR, find the measure of angle R. right, so what am I looking for? This angle. An angle R goes with what angle? Angle L. Now, I have them nice and lined up. But hopefully you agree this triangle could be spun any way. And it wouldn't change the fact of where everything is, right? I mean, this thing could be spun, right? And L is still the angle that's corresponding, right? Here, let me put it like this. Kind of get it straight. Stick an L in it. Let's see if the L will travel with it. I don't know if it will. Figures. Nope. So anyhow, that angle is the one that always corresponds. So again, I have them nice and lined up for you, but it doesn't always have to be that way. Go away. All right. So that's the concept. So hopefully you understand then we are after that angle. So this one requires a little bit of thought. If this one's 80, do you agree this one is 80? Will that allow me to find R? What will I use now? What knowledge in my brain will I use to find R? R. Connor? Do you know how many degrees it is? Yeah. Okay. I was just wondering, you had your hand raised, so I thought maybe you had something for me. What will you use to figure out R? Kaylin? No, that wasn't a right hand. I thought it was a raised hand. Kirsten? And say it's 120? No. Raquel? Raquel? How do you know it's 60? Ah, Raquel remembers that the three angles of every triangle equals 180 degrees. Yes, it does. And therefore, 40 and 80 is 120. 120 plus what equals 180? And Raquel rightly said 60. Very good, Raquel. Must be the R's. Okay, does that make sense? You remember that now? Three angles of a triangle equal 180 degrees. Okay, that's an important one. And so a problem like that is how you'd do that. Now, in this second question, we got to find PR. So PR is the distance from P to R, so it's this side right here. So that's what we want, PR. So remember, we're going to use a proportion, and it's always best to put what you're solving for where? Top left, right? Is that the only way to solve it? No. Is that the easiest? Oh, yeah. Okay. So PR is the big one, right? That's the big triangle. So for me, my tops are going to be the bigs, and my bottoms are going to be the littles, right? So what side goes with PR? Well, you can look at the lettering, right? Here's PR, right? First and third. So would you agree JL goes with it? And again, these are lined up nicely, so it's easy to see. But sometimes the triangles can be spun, and they don't line up so nice. You're going to go by the lettering. So do you agree we need JL on the bottom? Now I need another top off the big. Which top am I going to choose? Am I going to go PQ or am I going to go QR? You got to use QR because QR is the one that has the number with it. Again, I'm just showing you the letters. We'll put the numbers in a minute. And so if I went QR, then I got to go KL on the bottom, right? What corresponds to QR, KL? And again, letters, second and third letter, right? Okay, so really, Most students will go right directly to the numbers, and that's okay. I'm not saying you got to do it in letters first, but you got to make sure you're putting the things in the right spot. So what is the distance of K of JL? That's a 6. What is Q to R? 4.2. And what is K to L? 3. So there's our proportion, right? And because we put it in the top left, all we got to do is multiply both sides by 6/1, right? Hey, we got decimals, but we can R-bum this thing. And PR is going to be 4.2 times 2. And if you're grabbing your calculator, shame on you. PR equals 8.4. But if it were a quiz or test, feel free to make sure that you're okay. 8.4, figured it out. And actually, so everything's doubled. Okay. Which therefore, now that we know, no, everything is not doubled. Everything is, all right, doesn't matter. Leave it. We still have another side that they could ask you for. We'd have to do the same thing. Form a proportion, no 3 to the 4, and voila. Any questions so far? Peebles? Okay. See, here's a relationship. The ratios of the perimeters equal the ratio of the sides. So you can figure out perimeter the same way. So notice I have the perimeter of triangle ABC over the perimeter of triangle XYZ. So now I'm just going to list the sides of triangle ABC. So you got a side AB, right? You got a side BC. You got a side CA. And now I'm doing the bottoms, right? What side goes with side AB? And hopefully you think XY, right? And what side goes with side BC? And hopefully you look and say, oh, it's YZ. Again, we're reading the order of the letters, right? And CA on the top gives you a ZX on the bottom. So again, how would you use this? Well, in this situation, you're going to use the perimeter because that's what you're solving for, perimeter, and any one other of them. So perimeter of ABC equals BC over YZ, right? If that's the other ones you know. And you can either solve for one of the perimeters if you know the other, or if you know both perimeters, you can solve for a side. Normally, you're going to know one of the perimeters, and you're going to solve for the other. Same exact way. Whatever you're looking for, top, left, 3 things you know, voila, you're there. Okay? Capiche? Great. Let's roll on. All right, be careful on this one. Students get this one confused. So perimeter's nice. It's normal. However, and ever, the ratios of the areas is different. The ratio of the areas equals the ratio of the square of the sides. Don't lose sight of that word square. So again, when I go AB, I got to go AB squared. When I go BC, I got to go BC squared. When I go CA, I got to go CA squared. And so on the bottom, when I go XY, I got to go XY squared. See the ratio of the sides squared, the square of the sides. And this bottom's got to be YZ squared. And this bottom has to be ZX squared. Or vice versa, right? You can flip it up the other way. Okay, so be careful. That one you have to remember. What have I noticed in all my years of teaching? Students forget to square when doing the areas. Okay, you're going to get it wrong. You're going to get it wrong. So perimeter, you're adding. It's just normal, same ratio. But area, remember, to get the area of a rectangle, it's what? Base times height. You're multiplying. And that's why we got to square those sides. You can't forget that. If you forget that, you're going to get it wrong. Okay, so here's a quick example. We have two quadrilaterals. Notice it tells us the area of quadrilateral DEFG. You name the vertices and go in order. Okay, and we want to find the area of RSTU. I'm going to make a proportion. Right now, no. Okay, so I got the area of RSTU on the top. What's going to go on the bottom? What's going to go on the bottom? So the area of DEFG, is that what you're saying? See, I have area on the top. I need area on the bottom. Area over area. So now RSTU is on the top, right? The right-hand one is on the top. So what side of the right-hand one am I going to use? Well, I only have one thing with a value, right? I have to use TU. But remember, TU is... No, TU is supposed to be squared. Again, we'll put the numbers in a minute. And I don't mind you going right to the numbers when you do homework, but I want your notes to be clear where we're getting these from. And again, because I went TU, I have to go FG, right, on the bottom. And again, that's got to be squared. Now, again, these are lined up nice. Are they always lined up nicely for you? No. But the lettering will tell you the order. So now let's go ahead and sub in. So I can just use A now on the top. It tells me the area of DEFG. It's 40 units squared. TU is 12. Remember, you got to square it. And FG is 6. And remember, you got to square it. Now, by the way, how would you finish this off? Well, again, multiply both sides by 40 units squared, right? Because again, the way we set it up, we put what we're looking for in the top left, makes the problem easier to finish. That one I just punched in my calculator and hope that it comes out even, because that's a lot of reducing. So just do 12 squared. Go ahead, break out your calculators. 12 squared times 40. The units are squared, not the 40, right? It's 40 units squared. So 12 squared times 40 divided by 6 squared. Make sure you can punch your calculator correctly. And if you did it right, you'll get a nice round number. Actually, you should get a square number. Yeah, nice round number. Raquel, you got something for me? What do you got? That's not what I got, right? 160. Anybody else get it? Yeah? Did I punch it wrong? No. It's kind of dyslexic. A couple days for me, so I don't know what I've been punching. All right, what is that? What do we got? 40, right? Times 144 divided by 36. 160. Is that what you said, Raquel? So 160. And did you put units squared? Awesome. 160 units squared is the answer. 160 units squared. Okay? Does that make sense? Questions on that? So what is students for... Adriana? By punching it in, you mean? Okay, so did you punch in 12 squared times 40? Right? 12 squared times 40. divided by 6 squared. 12 squared times 40 divided by 6 squared. Andrew? Remember, it's only the units. This is 40 units squared, not 40 squared units squared. Okay? Any other questions on that one? All right, last thing, real quick, and this isn't a big deal, and you guys know this. Scale drawing or scale model. All dimensions are in the same scale. If you have HO scale trains, I think they're 1/32. So you'd have to blow it up 32 times to get a real size. 1/32. You could also say ratio. The same idea. So you have a similar figure. That's what scale models are. Anybody do model cars or ships or airplanes or anything? Okay, this is back in the day before we had stupid thumb games that we did, played things with thumbs. We actually put models together and stuff like that. Played with trains. So you can't move it with your finger. So do it. All right, anyhow. But scale and ratio. You know, on this ship, the scale is 1/70, and we could ask what's the size of the mast. Well, you could get a ruler out, measure the mast, and now make a proportion, right? So, you know, that's how you would figure it out. You make a proportion out of it. So if I ask the size of the mast, let's suppose I call that X. So the top is the mast. And so on this one, you're best using fraction. So mast and whatever you measured, and I don't know, I'm just making up a number. How what does that look like? 2 inches on your paper, maybe? Okay, and let's say you measured it to be 2 inches. Then your other one is going to be your scale, and I'd use 70 on the top and the 1 inch on the bottom, right? Feet to inches. Because my mass is going to be in real life feet, right? So many feet over 2 inches. And again, you would solve it the same way, 2/1, right? Your inches would divide out, and 140 feet per se, just an idea of what you're doing with that, right? Make a proportion. All right, my time's up. You can see 1 through 4, 7 through 10, 16, 17, 22, 30, 52. Hope you enjoy your weekend. Come to the Fall Harvest Festival.